So I spaced out 14 spaces where I want to put the LEDs, and I marked them with Sharpie. This is on the back side of where I sewed the Pro Wick, so that it's easier to connect them on the underside, so there won't be any shorts. And I will set aside 14 LEDs and 14 resistors, but I also want to test these to make sure they work. So I have this battery pack with a 400 ohm resistor, which is two 200 ohms. I have this because if I directly put 6 volts into one LED, it'll burn out that LED. So I have this resistor to limit the current. And so I'll just test one. Though I know it's a positive because it's a longer lead rather than the negative, which is a shorter lead. And it also has a skinnier structure on the inside, while the negative has this fatter structure on the inside. So we'll connect the positive to the positive and the negative to the negative, and it'll light up. So now that I've checked all the LEDs and make sure that they work, because if one is burnt out, then the whole line will be burnt out because it's connected in a parallel circuit. So now that's done, I want to connect the resistor to the LED. From their diagram here, I figured that this red band was the first in the front, and then the brown band is the back. So I had this connecting to the positive and this one connecting to the LED. So it goes, the flow of current will go from positive, the first red one, to the brown one. And so let's assemble 14 of these. So first off, we want to calculate the resistance of our resistors per LED in this parallel circuit. In order to do that, we know that I looked up in Google that one like AAA battery or AA is equal to 1.5 volts. So we know the voltage, and we'll put this in Ohm's law, which is V equals IR. And if we have two batteries in series, it'll multiply by 2, so that will be 3 volts for V. I is our current, which is what we want to try to achieve at 0.015 amps, which is 15 milliamps. And we want to know resistance. So it's just dividing by, so R equals 3, which equals 200 ohms. So this is a given because it's already in our package, but to calculate it, you'll just use Ohm's law here. And in order to calculate how long your battery will last, you'll just be using the milliamp hours. So I googled it for a AAA battery. It is about 1,000 milliamp hours for if you use the AAAs. So then we just multiply our milliamps by the amount of LEDs we'll have, which is one. So then you'll divide 1,000 divided by 210, which equals about 4.7 hours. So to assemble it, I'm going to bend the positive side of the LED so that it's like that. And then I'm going to bend it that way. So like this, using the pliers. And then I'm going to take a resistor and connect it, looping it around the positive side of the LED. So I'm going to take the brown side, connecting it to the positive lead. And just wrap it around. So in the end, it'll look like this. And I'm going to hook it up to these clips, alligator clips, so it's easy for me to solder it. So we can start soldering this one.